Hi everyone! Today we're going to be talking about points, lines, and planes. Our objectives for today are that students will be able to identify and model points, lines, and planes, and you'll be able to identify intersecting lines and planes. Let's get started. Why is it important that we learn about points, lines, and planes? Well, here's a real-world example of when you would use them. So on a subway map, the locations of stops are represented by points. The route the train can take is modeled by a series of connected paths that look like lines. The flat surface of the map on which these points and lines lie is representative of a plane. So next time you see a map or you use a map, you're using geometry. So what exactly is a point? A point is a location. All right? It has no size or shape. We always use a capital letter to name a point. So for example, this point right here, we would call it point A. And what we would write is we would just say point, capital A. X. A line is made up of points. Any two points form a line. So if we can connect 2 points together, we've got a line. A line has no thickness or width. And we name a line by any 2 points on the line, or we can use a lowercase script letter. So for example here, we can name this in actually 3 different ways. We can call it line XY, and we can put a little line with arrows above it. That means line XY. We can write out the word line, and then use lowercase script letters X and Y. And then the third way we can write this line is we can call it line N, because there's a lowercase script N, and that represents this line, as you can see in the picture right over here. All right, now we've got 2 different kinds of points. We've got collinear points and non-collinear points. So collinear points are points that lie on the same line. So X and Y would be collinear points because they lie on the same line. Non-collinear points are lines that do not lie on the same line. And we have to have at least 3 points to classify them as non-collinear. So for example, if we had a third point here, right here, let's call this point Z. Then we would say that X, Y, and Z are non-collinear because they do not lie on the same line. All right, now a plane. A plane is a flat surface. Let's go ahead and copy that down in your notes, made up of points. Any 3 points make up a plane. A plane extends indefinitely in all directions, meaning it goes on forever in every single direction. Now we name a plane by any 3 non-collinear points on a plane. All right, and the key word here is non-collinear. So they have to be 3 points that do not lie on the same line. So and we could use an uppercase script letter. So for example, in this problem right here, there's an uppercase P that represents this plane. So we could call this plane P. Or we would need to name it by 3 non-collinear points, J, K, and L. So, or we can call this plane J, K, L. 2 different ways of writing it, 2 different ways of naming it, all right? Now, coplanar points are points that lie on the same plane. Non-coplanar points would be points that do not lie on the same plane. So if we had another extra point over here that was on the outside of our plane, let's call this point M. That would be non-coplanar points. J, K, L, and M would be non-coplanar. All right, wrapping up our vocabulary for today. So we've got intersecting lines and planes. So two lines always intersect at a point. All right, so these two lines intersect at point P. Now two planes always intersect at a line, where these two planes, plane L and plane M, intersect at this line right here, at line K. All right, now let's practice a little bit in naming points, lines, and planes. So number one, we're going to use this diagram on the right to name the following. First of all, we want to name 4 collinear points. So we want to look for a line that has 4 points on it. So we've got H, N, K, and I. So there's 4 collinear points. They all lie on the same line, on line R. So let's write those down. Points H, N, K, and I. Now we want to name a line that contains point M. So there's lots of different options here. We know it's this line right here, but there's lots of names we can call it. We can call it line P, we can call it line MN, we can call it line NO. Alright, so let's list some of those out. Line P, we can call it line MN, we can call it line NO, we can call it line MO. It's all the same line, just lots of different ways of naming it. Now we want to name a line that contains the points H and K. So a line that contains both H and K would be this green line, once again, would be this line right here, line R. So we can list it out in a few different ways. We can call it line R, we can call it line HN, we can call it line NK. We want to probably use H and K, right? Because that's what's in the problem, so we could call it line HK, and there we go. Lots of different options, and there's a few more too, all right? So there's not just one right answer here. Now another name for line Q, which is this line right here, all right? So this line right here, we can call it line JK. We can call it line KL. We can call it line JL. All of these would be correct names, other names for line Q. And last but not least, the intersection of lines P and R. So line P and line R, they intersect at point N. All right, so we can just use a capital N for that. All right, number 2, we're going to use this diagram, which looks a little different. We've got a plane. We've got our plane right here, plane. And we've got a line going through the plane. Think of a pencil going through a piece of paper, through the center of a piece of paper, going up, all right? That's what this diagram right here looks like. So, first of all, we want to identify a line containing point F. So that's this point right here. So the line that contains it would be this line right here. Lots of different ways we can name it. We can call this line J, all right? We could also call it line DE. We can call it line EF. We can call it line DF. Just different names for the same line. Now another name for line K. So line K is this line right here. Another name for line K would be line CE, right? Because C and E lie on that line. We could call it EB. And you've got to put the arrows on top, all right? The arrows with the line on top. Or we can call it line CB. 3 different names. Any one of those 3 would work. Now a plane containing point A. So point A is this point right here. And the plane that contains it would be plane M, all right? Because we always want to look for the capital script letter that names the plane. So we would call this plane M. All right, then the next next problem is an example of 3 non-collinear points. All right, so 3 non-collinear points, we need 3 points that do not lie on the same line. Non-collinear, not on the same line. Okay, so if you break down this word, not, co meaning the same, linear means line, so they're not on the same line. Let's see, 3 points. We can say B, F, and E. All right, that's 3 points. They do not all lie on the same line. You could also say A, B, and E. That would work too. Or A, B, and D. All of those combinations would work. All right, so I'm just going to say A, B, and D. Okay. Last but not least, the intersection of plane M, so we've got plane M and line K. So this line and this plane, that would be point E. All right, that's where they intersect. All right, I want you guys to try to do number 3 on your own. All right, so when I say go, you're going to pause your video. You're going to try to do number 3 on your own. When you unpause it and come back, I'll have the answer written on the screen and we will go through it together. So go ahead and pause your video now. All right, so for A, 3 coplanar points, meaning 3 points that are on the same plane. So 3 points that lie on the same plane, you could have said YVW, they lie on the same flat plane, the square, YVX, XYV, WXY. Now you could have also said 3 points that made up a triangle because each triangle in this pyramid is a plane as well. So you could have said WXZ, you could have said VWZ, VYZ, all would have worked as well. Now a plane containing point X. So I said plane R because it's this bottom plane right here, all right? The floor or the base of the pyramid is plane R, and that contains X. Now you could have also said this triangle right here, this face of the pyramid, all right? So that would have been plane XWZ. Or you could have said plane XYZ. The other side, this triangle, the other side of the pyramid would have worked as well. Now the intersection of plane R and plane ZVY. So ZVY is this triangle right here, the left face of the pyramid, and plane R is the floor. So the intersection of 2 planes is always a line. So it's going to be line or line segment VY. How many planes appear in this figure? So we've got the 4 faces of the pyramid, all right, the 4 triangles that make up the pyramid, and then the base or the floor, all right, the bottom of the pyramid, which is also plane R. So 5 total. And how many planes contain point W? Point W is this one right here. So how many planes contain it? This face contains it, this face contains it, and the floor, the base of the pyramid, contains it as well. So 3. If you have any questions on that, please raise your hand, call me over so I can help you. Otherwise, let's move on to our final example. All right, last but not least, number 4, we're going to use the diagram to the right to name the following. So the intersection of lines L and M. 2 lines always intersect at a point. So line L is this line right here, and line M is this line right here. They intersect at point E. All right, so we're just going to put a capital E. Oops, sorry about that. There we go. Another name for plane Q. So plane Q is this plane right here because we've got this capital Q. So another name for it, we want to use 3 capital letters, 3 points that are non-collinear that lie on the plane. So we want to say IFE or IFG or IEG. All right, all of those different combinations would work. All right, just they have to be non-collinear, so you have to use I and then any 2 of the letters that lie on line M. So we're going to say plane and IFE. And then points are, it's asking you, are points D and E collinear or coplanar? So if we're looking at D and E, They lie on two different planes. They do not lie on the same plane. Point D lies on plane P, and point E lies on plane Q. So D and E are not coplanar. All right, so we can cross out coplanar. Now they do lie on the same line. They both lie on line L, so they are collinear. And then how many times do plane P and Q intersect? The answer to this question is 0. They do not intersect. They never will meet. And we call these parallel planes because they will never intersect. All right. Hope you learned a thing or two about points, lines, and planes today. If you have any questions, please raise your hand, call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day.